Whether it's the bright lights and dazzling colors of the Las Vegas Strip, or the blinding sun that forms this desert mirage, all too often, it's the simple illusions of light and shadow that warp your brain's perspective of reality. To show you what we mean, let's play a game. Take a look at this desert halfway around the world. What do you see? A bunch of big camels, right? Except there are no big camels. Those camels are really shadows thrown by the actual camels, which are the light brown figures on the sand. This photo by National Geographic photographer George Steinmetz is a perfect example of how your brain makes snap judgments about perspective. Your brain has a tendency to assume that whatever you're looking at must be at eye level. After all, you're probably only used to seeing camels from one angle, the ground. Which is why you might have mistaken these black shadows for actual camels. But it only takes a split second of closer analysis for your brain to perform what scientists call mental rotation. This is your brain's way of creating a 3D image of what you're seeing, and then mentally changing the angle to give you a better point of view.
Whether it's a deceptive camera angle, forced perspective, or a trick of light and shadow, the slightest change in perspective can cause your brain to leap to false conclusions, as you're about to see in this next experiment.
Take a look at this image full of bumps and craters. How many bumps do you see? Go ahead and count them. Got your answer? Did you say 4 bumps? Keep a close eye on the image because we're going to turn it upside down. Now how many bumps do you count? Has the image changed to show 6 bumps? How did flipping this image 180 degrees change the craters into bumps and the bumps into craters? It all has to do with your brain and the sun. Here to explain is Professor Jim Cohn of the University of Virginia.
Over hundreds of thousands of years of human evolution, people use the sun to help determine time of day and location. So your brain instinctively understands light comes from a single source above us, and that shadows are created by the light's direction. When your brain sees lighter shading on top of the circle and darker shading at the bottom, it assumes the darker shading is a shadow cast by a light source above and behind the object, meaning that circle must be a bump. But in the case where there's darker shading up top, that means light isn't hitting that area, which is a signal to your brain that this circle must be a crater.
Light, shading, and shadows help your brain give 3-dimensional shape to the flat 2D image of the world projected onto your retinas. To enhance that 3D perspective, your brain also analyzes the distance, depth, and height of everything around you.